All right, guys. This is going to be the last video that we have for a little while. And I was running out of time and space at school, so I had to come home and do some stuff here. I'm going to be honest with you, the pens that I am going to be using here may or may not be amazing, but I'm going to at least say that we've got a couple things that we're going to be doing a little bit differently. And if I've got to switch to just straight up pencils and pens, that's fine too. So we're talking about fractional equations. Now, this is what the difference is between fractional equations and the equations that we've been working with before that have got fractional coefficients. The difference between this and the other is that with the fractional equation, we have variables in the denominators. Okay. The difference that's actually super important about this is when you have variables in the denominators, that means that there's some values that if you plug them in there, they might make it so that it doesn't actually work. What I mean by that is that you may have something that if you plugged it in, you would have a zero in the denominator of a fraction. Now, we're not allowed to have a zero in the denominator of a fraction. So it's just something here where if as long as you remember that no denominator equals zero, we should be fine. And there's a couple things we're going to be looking at for that. But for the most part, it will be okay for us to do this. Now, I'm going to go and just do a couple really quick examples of this to give you a chance to go through it. Your self-check is going to be on page 249 with 1 through 23 odd. Give it a shot. Take a look and see what it's going to look like and see what you can do. I'm going to try a different color to see if this is going to work, but I think we should be okay. So a really quick example of something like this would be like if I start off with 3 over x squared minus 7x plus 10 plus 2 is equal to x minus 4 over x minus 5. Okay, so taking a look at something like this, there's just a lot of craziness there, right? Like it's a lot of the same things that we have done over the course of the entire chapter, kind of dealing with simplifying things, putting things together. And so ultimately, what you're going to have to do for this is really similar to what you've been doing before. And that is going to be you factor all of your denominators, you see what you can get, and then, well, we're going to have to solve this for x. There is a crap load of x's here. So what I would do first is let's deal with this part that's over here. And anything you can factor, let's do that before we do anything else. So I'm going to factor this. And if I'm going to factor this, one of the things that's going to be important for us to think about is that a lot of times when we're doing this, if we have something that's already a denominator, it is likely that that is going to be one of my factors over here. We talked about that a little bit earlier, but let's just kind of see what we're going to get here. Like I know for a fact I'm going to have an x and an x here. Now I need two things that are going to multiply to a positive 10 and add to a negative 7. Negative 5 and negative 2 would absolutely work for something like that. And so these two things are going to work for this. And that just means that when this is factored, this is what I've got. It's the same thing that I have over here. Now, I'm going to rewrite this whole problem just to make sure that we have a place to be able to look at it all at the same time. So we will have 3 over x minus 2 times x minus 5 plus 2 is equal to x minus 4 over x minus 5. Just like what we did for the other problems, when we have a thing like this and we're going to be trying to get rid of all of our denominators to solve it, the first thing that you want to find again is your least common denominator for the entire problem. Well, I mean, it's kind of easy in this case. There's no denominator here, so that's just a 1. I've got an x minus 5 that I need, which is the same as here, and I'm also going to need an x minus 2. I kind of love these when they are simpler like this because they're already factored and I don't have to look to see what things I'm going to be going through. Now, what I want you to do before you multiply through by that is to take just a second and to have us look at it and say, okay, here's what we're going to be doing. I'm going to be checking something right now. Hold on. I have a feeling that I'm going to be told that I'm not supposed to be doing this because I am too loud. Yeah, give me just a second. I'm going to be doing a quick text for something like this. So hold on. Let's hope that that works out okay. It will probably not work out okay. We'll see. You guys get to watch this right now. All right, cool. I'm glad you guys had a chance to sort of see this. Everything's going to be fine. All right. This is where you guys said I should edit it. I'm not going to edit it. And the reason I'm not going to edit it is because I don't know how. So you guys, I'm sure, can show me, and that's going to be lovely. All right. What you have to do, back to where we were at before, is when we've got a problem set like this, and we've got some variables and denominators, you just have to say what x can't be, because that limits the values that you have. And if you get something like that, it just means it's not going to work with our problem. So like here, x is not going to be able to equal 2, because if I plug in a 2 there, it's going to make that equal to 0 in the denominator, which doesn't work. Here, I know that x is not going to be able to equal 5, and it's going to be the same right here for x not being able to equal to 5. So as long as I remember that those two things are in place, we should be fine. So if I go through this, solve it, and I get one of those two answers, it just means it's not a solution that will work. Okay? All right. Now, we're going to take this. We've got our least common denominator. We're going to multiply through on both sides of that equation by x minus 2 times x minus 5. Here and here. Okay. So when I bring that in, I'm going to bring it into both of those, and I'm going to bring it in here. Okay, well, it's not too hard to actually do that. When I bring this in here, both denominators are here. So x minus 2 will cancel, x minus 5 will cancel, and the only thing that I'm going to be left with here is a 3. There's our plus. Now, when I bring it in here, there's literally nothing that's going to cancel, and so I'm going to put a 2 there, and I'm going to have x minus 2 times x minus 5, because both of them, when I multiply them in here, don't have anything to cancel out with it. Then on this side here, my x minus 5 will cancel out with there and there, and I'll be left with x minus 4 times x minus 2. Okay, so we're going to have a little bit of work that we have to do here, but it shouldn't be terrible. I don't have any denominators with variables anymore, which is lovely. At this point, now what I need to do is multiply everything out and then get us our solution. So it's not bad. What I'm going to do first, not doing anything with the 3 yet. I'm going to eventually have to distribute that 2. But when I multiply this out, x times x is x squared. Negative 2 times negative 5 is positive 10. And then what we have to remember is we're doing the outside ones together and the inside ones together. So this will be negative 5x and negative 2x, which when I put them together is going to be negative 7x. Okay. And we're going to do the same thing over here. I'm going to have an x squared from this one, a little space. Negative 4 times negative 2 is a positive 8. And if I do a negative 2x and a negative 4x, it's going to give me a negative 6x right there. So that's multiplied out. You guys can do it with the box or FOIL it out as well, but for right now, this is probably easier. Now I'm going to distribute that 2 and combine like terms over here. So we will have 3 plus 2x squared minus 14x plus 20. On this side, I've got x squared minus 6x plus 8. And then if I put this over here with the 20, we'll have 2x squared minus 14x plus 23 equals x squared minus 6x plus 8. Okay, I need to get this equal to 0 for me to be able to solve it. So I'm going to move these over to this side so that I have a positive x squared, because I've got 2 of them here and 1 of them there. So I'll subtract x squared. I'm going to add 6x, and I'm going to subtract 8 from both sides. Now, on my right-hand side, I'm going to get a 0. 23 minus 8 is going to give you 15. Negative 14 plus 6 is going to be negative, I believe, 8x. And 2x squared minus x squared is just x squared. That is a much easier thing for us to factor. So if I do that, I am going to have x and x, negative 3 and negative 5. And so the two solutions I'm going to have to this equation then are going to be x is equal to 3 and x is equal to 5. All we have to do then is go up and check to see if those won't work. In this case, x equals 3, totally fine, because that's neither of these. But if we look right there, because of the fact that it automatically says that if I have a 5, I plug it into the original problem, this is going to cancel out. This is actually not a solution because it's not going to work. Now, when we get a solution for a problem like this that doesn't work with the original problem, doesn't mean you did anything wrong. It just means that it doesn't end up working out. What we call that when we're done is we call that an extraneous root. So I'm going to just write this right above here, extraneous root. And when I say that, it just means extraneous, meaning like an extra, one that isn't going to be something that's actually going to work. And a root is another word for a solution. So when you have something like that, it's just an extra solution that doesn't work because it makes the original problem undefined. Okay, really quickly, I think I only have one more problem to go through to make sure you guys know what to do. And then we're going to just kind of rock it on out and we should be done with it all. Okay, so last example with what we're doing here, I am going to have, oh, here we go, 5 over x squared plus x minus 6 is equal to 2 minus x minus 3 over x minus 2. Okay, I'm going to factor this guy here, and factored x and x plus and a minus has to multiply to a 6, and it's going to add to a 1. So with that negative there, I'm going to have a positive 3 and a negative 2, because 3 minus 2 gives you 1, negative 3 times 2 is 6. Okay, so this is my denominator. This is my fraction. This, and I've got the fraction here. Okay, so basically, first thing I'm going to do is say, I know that x cannot equal, in this case, it can't be negative 3. In this case, it cannot be positive 2. This is okay, and positive 2 works for here. So this right here, this will be what we're going to call my domain. Those are the values that I'm not able to use, and what I'm going to check to the end for to see if I'm going to have any problems that go wrong with it. And I can also tell you that my least common denominator is going to be those two together for the same reason the other one was, because there's nothing here, and I've got an x minus 2 shared. You might see my cat in a second here. There she is. I need you not to be right there. Okay, so we've got x plus 3. I do also want you to know that I'm not going to spray this cat like I said that I did for that original problem, but she just wants attention. So, okay, I'm going to take this and distribute it to both sides of the equation. So we're going to have x plus 3 times x minus 2, and I'm going to multiply it by the left side of the equation. So 5 over x plus 3 times x minus 2, that comes from this side, is equal to, and then I have this same distribution, x plus 3 times x minus 2, and I'm going to multiply that by this whole side here, 2 minus x minus 3 over x plus 2. Okay. Now, when I multiply that in, what's going to happen on this left-hand side is the x minus 3 is going to cancel, or x plus 3 is going to cancel, the x minus 2 is going to cancel, and we will be left with just a 5 over here. Then here, with the 2, if I multiply this in, 2 has nothing on the bottom to cancel with it, so I'm going to leave both of them there, x plus 3, x minus 2. And then if I distribute this in here, the x minus 2 cancels with the x minus 2, and I will be left with the x minus 3 that was on the top there, and this x plus 3 that is left over here. Okay. Well, this shouldn't be too terribly bad. Most of our work's just on this side. We're going to have to bring over a 5. Okay, so let's do some work. Here's 5. There's 2, and I'm going to have to multiply this out, and I'm going to have to multiply this out. So here and here is x squared. 3 times negative 2 is negative 6. And again, negative 2x plus 3x is going to give me a positive 1x. It's the same thing I had from the original, but that's kind of helpful to look at it here. Here, these are conjugates. So when I multiply them, I'll have x squared, we'll have minus 9, and because it's going to be positive 3x and negative 3x, it'll go away. Okay, so now I have to distribute the negative here, and I've got to distribute the 2 here. So we'll have 5 equals 2x squared plus 2x minus 12 minus x squared plus 9, because if I distribute that negative to there, it's going to be this. Now I'm going to combine my terms on this side. I'll bring that 5 over in just a second. 2x squared minus x squared gives me x squared. Here is my only single x, so it's 2x. Negative 12 plus 9 will be negative 3. And then if I subtract that 5 from both sides, I'm going to get that 0 is equal to x squared plus 2x minus 8. Awesome. Super easily factorable. X and x. It's the negative 8. And so 4 and 2 is what I'm thinking about it. And because I want this to be a positive 2, it will be a plus 4 and a minus 2, because 4 minus 2 is 2, and 4 times negative 2 is negative 8. That means that the solutions I'm going to have for my problem are x is equal to 2, and x is equal to negative 4. We look up back to our original ones. Things that cannot be are negative 3 and 2. So right here, this one is an extraneous root. This one, though, is a solution. So you will be fine with an answer like that. Okay, guys, it's late. You are going to have some practice with this to be able to look at. We'll talk more about it when I get back on Tuesday. But in general, it's kind of what you're going to be doing for these, and you're checking for your extraneous roots. So cool, and I will see you when I get back in a little bit. If it'll let me stop recording. See how that's going to go. It's not that. There it is. All right. Bye, y'all.